Hello everyone, today we are going to calculate the size of a tree. What does the size of a tree mean? First, let's check out. See, the size of a tree is basically the number of nodes which are contained in a tree. In this case, like I have written, size of a tree is number of nodes in a tree. In this case, number of nodes, if you will count n1, n2, n3, n4, n5 and n6 are there. There are 6 nodes. Basically the size of the tree becomes 6. So to calculate the size, let's go and do the coding. See, I have already done in our previous tutorial. We have already made the node of a tree that is contains data left link to the left subtree and right link to the right subtree and provided it in a constructor. Now, one more thing I have done is made a tree class where the functions of a tree can be written and provided the root of the tree in the constructor. And in the main class, I have represented a tree with 3 nodes and connected them to form a kind of tree which looks exactly like this. Now let's do coding and write the function to calculate the size of a tree. So public int, that is the size, will be returned in an integer form, calculate size. I'm using cal size to represent the size of a tree, and here in cal size I'll pass tree node and I'll name it as root only, because root of the tree will be passed in the cal size function. If null pointers check will also be applied, and one more thing to be done, initially I'll have to check whether root is null or not. So I'll write root equal to null, then simply return 0. That is, size of the tree is 0. Else, what I will have to write a recursive function. Each time one node will be visited and one extra count will be added to the recursion process. So every time one node visiting one node will increase the count to 1 time, and in this way total number of nodes will be visited, suppose n, then n number of nodes will be counted. So in the recursive process I will return what I will return. I am writing this. I will call it recursively, so basically I am copying this much only. I will add 1, and what I will pass here in this function is root dot left for left subtree and root dot right for right subtree. So 1 will be appended each time, 1 will be added each time a node is visited, and if the root becomes null, then 0 will be returned. So in this way size of the tree will be calculated. So let's calculate the size of the tree. Here, as you can see, I have 6 nodes and all of them are connected to one another. So here the size should be printed as 6. So let's create my tree function, my tree class, and object of my tree class should be made first. My tree, let's name it as empty is equal to new my tree, and here I will pass n1. As you can see in the pictorial representation, I have written n1 as a root node. So I have done the joining also as a root node as n1. So I am passing n1 as a root node, and what I will do, I will simply call the empty dot calculate size, that is, I will cal size function, and I will pass the root node of mtree and get the size of tree. So I am simply printing out this out the size of our tree is empty dot size cal size, and here I will pass the root node, that is n1, not n1 but the root node of our tree, empty dot root. and let's see the what we get as a size. Run as Java application. As you can see, 6 got printed as we have 6 nodes in our empty, and all of them are connected. So let's do one thing. Let's remove one node. That is, let's remove n6 from our tree to check out whether the size decreases or not. So I am commenting this n3 dot left. That is n3 dot left. I am commenting this. So n3 got left out. Now let's check whether what gets printed. It should print 5. This one got removed. Yes, 5 is coming. Thanks for watching the video.